Hello, good day viewers. The title of this tutorial is Understanding Inverse Trigonometric Functions. So far, we have learned how to find the ratios of all the spatial angles, including their coterminal angles. So what are these inverse trig functions? All right, first of all, I would like to draw my unit cycle here. And throughout this tutorial, I would like to be using degrees. We are not going to solve problems, rather understand what this inverse trig function means. If this is a unit cycle, right, I would like to use 30 degrees as reference. So I will be working with 30 degrees. Let's assume this is 30 degrees. The coordinate at that point is what? Root 3 divided by 2 and 1 divided by 2. Which means that cosine of 30 degrees is root 3 divided by 2 and sine of 30 degrees is 1 divided by 2. But the problem is, if you come to the second quadrant, you realize another 1 divided by 2 here at 150 degrees. This is 150 degrees. The coordinate at that point will be negative root 3 divided by 2 and positive 1 divided by 2. Remember, we are always looking for the output. The output, sine of whatever angle you are looking for, that angle will serve as the input. Take a look at this. Sine of 30 degrees equals 1 divided by 2. 30 degrees is our input, while 1 divided by 2 is our output. So whenever we are going to assume that sine is a machine that processes something 30 degrees and give a result as 1 divided by 2. So whenever an operation acts on the input to get exactly one output, then we say that is a function. But talking about inverse, it means we have to undo sine, and that is what? Sine inverse. It is either like this or you call it arc sine. These are what? Inverse trig functions of sine. So how do we do that? I know that there are ratios of many angles, sine ratios of many angles, infinitely many, that can give us 1 divided by 2. Another one is 150 degrees. From standard position down here is 150 degrees, right? Which means that sine of 150 degrees is equal to 1 divided by 2. We have no problem with this because the input are not the same. They are unique. But the outputs are exactly the same. And again, coterminal angles. You can obtain coterminal angles by adding or subtracting 360 degrees. So if you add 360 here, you have 390, right? 390 degrees will still be equal to 1 over 2. This is what I mean. Any angle on the same point with 30 degrees will be its coterminal angle. So if you make one rotation from here, you go around, you come back to where you started, you have 390 degrees. Since they are on the same position, it will still be 1 over 2. And if you go to this direction, which are negative angles, it's like you are subtracting 360, which I think will give you negative 330, right? So sine of negative 330 degrees will also be in the first quadrant, which will give you 1 divided by 2. So we have no problem with these ones. But let us look at it graphically. I want to explain something. Either sine or cosine, the highest output you can get is -1, because remember, sine depends on y-axis, so the coordinate here will be 0, 1. Here we have 0, -1. You can see the least you can have is -1 and 1, the highest. The rest are just fractions because they will be situated somewhere here, not up to 1, right? So therefore, the amplitude will be 1 to -1 to 1. So assuming that this is the origin, 0 degrees. So sine of 0, because I just want to illustrate sine x, for instance, sine x. So we could have 90 degrees here, 180 degrees, 270, and 360 degrees. If you come to the left, you may have negative 90 here, negative 180. Let me stop here. I know how it looks like, but I just want to show you everything. Sine of 0 is 0, so we place a star here. Sine of 90 degrees is 1. So under 90 degrees, we have 1 here. 180, we have 0. 270, we have negative 1. 360, we have 0. If you come here, negative 90 degrees, you have negative 1. So you have infinitely many points, but let me just connect this. Something like this. So for it to be a function, you can test a vertical line test. A vertical line test, you can draw a line vertically like this, anywhere you like. If it touches the curve at exactly one point, then it implies that that is a function. So we have no problem with sine, it is a function. But what about its inverse? If you want to find out whether it has an inverse or not, you can draw a horizontal line. So this horizontal line touches 1, 2, 3, 1, 2. You know we have infinitely many points because the domain is from negative infinity to positive infinity. Let me write it here. Domain, let me sine x, for instance, sine x. The domain are values of x, right? From negative infinity to positive infinity, so all real numbers. But the range, which are the values of y, from where to where? Negative 1 to positive 1. I'm trying to sort out something very interesting. So it means that sine function has no inverse. Yeah, it has no inverse because the output gives many inputs. You see, we have the same output, 1 over 2, 1 over 2, 1 over 2. But the output, if plugged into the inverse function, it will give many output. For it to be a function, the output must give one input. And the input must give one output. That is 1 to 1. So how do? We have to restrict the domain. From the origin 0, we look at a position where this line will not touch 2 points. So the moment you remove this, we have restricted the domain from the right of 90 degrees and from the left of negative 90. You see that the line will touch exactly 1 point. So now our domain, we restricted it to, where's my domain? This is my domain. It has now been restricted to negative 90 degrees to 90 degrees, which means that if you are taking inverse of any value for sine, it will give you values from here, here. Okay, this direction. Despite having other values here, it will not touch those values. It will only pay attention to smallest values on the right hand side. So therefore, if you take sine inverse of 1 over 2, it will not give you all of this. Instead, it will give you 30 degrees because 30 degrees is within negative 90 to 90 because the domain of the original function will be the range of the inverse function. Maybe I should illustrate something very important. So for sine, we have seen that if you're taking sine inverse of the output, it will only give you one input, which is within that range, negative 90 to 90, because we have restricted the domain, and the domain is the input. Therefore, if you're talking about inverse, it will be the output. So we only accept values within negative 90 to 90. Otherwise, it will not have an inverse. We are done with sine. Before we go to cosine, let me give you an example, something very important. Let's assume we have y equal to 1 over 2x. Let us just think of any input. Let x be equal to 2. So x equal to 2. We want to find the value of y. Half of 2 will be 1. You see that the input is 1. The input is 2. The output is 1. So the question is, what will be the inverse of that function? You can swap x and y to have x equal to 1 over 2y. Then you solve for y. By multiplying both sides by 2, you have y equal to 2x. So you should know that the input will now be 1. The output will be 2. And we're going to test it. You know, here the input is 2, but the input here will be 1. So let's see. If x is 1, 1 times 2 is 2. When x is 2, half of 2 is 1. So we have no problem with this. Since the input gives exactly one output and the output gives exactly one input, it means that function is 1-to-1. And it is what? Invertible. But what about if you have something like, I just want to show you why we used to restrict the domain. What about if you have y equal to x squared? Let's take a point like 3 for x. 3 squared is 9. So the input is 3 and the output is 9. So let's see what happens if we invert the function. So x equal to y squared. Take square root of both sides. You have y equal to plus or minus square root of x. Will the input and the output be 9 and 3? That's what we need to confirm. So the input now is 9. Let us plug it here. You have y equal to plus or minus square root of 9. Square root of 9 is 3. Y equal to plus or minus 3. It means that y can be 3 or negative 3. That's a problem because we expected to return 1 point. We imputed 1.3 and we got one single point. Therefore, we expect, after reversing the function, to get exactly one output. But in this case, it gives us what? Negative and positive 3 instead of 3. So how do we do that? We have to restrict the domain in order to make sure that x squared has inverse. In this situation, x squared has no inverse. Let me show you graphically before we come back to cosine. So the graph of x squared looks like this. Horizontal line test, it passed, it is a function. Sorry, this is vertical line test, it is a function. Horizontal line test, it touches the point at exactly 2 points. So how do we do that? From the origin, we are going to restrict it to, because initially it was from negative infinity to positive infinity as our domain, but now we would like to restrict it to 0, from 0 to positive infinity, something like this. So let's see what happens. If you restrict it from 0 to positive infinity, it will return only 1 point because you can see the horizontal line test. It touches only 1 point. So for example, if you have y equal to x squared, if x is 3, maybe somewhere here, y will be equal to 9, right? Y will be equal to 9. If you plug in 9, it will give you back 3 because negative 3 is normal because I have removed this portion. So this is why you have to restrict the domain in order to get it inverse. Otherwise, it will not have inverse. So let us talk about cosine. We have seen that by taking sine inverse, it returns values within the first and the fourth quadrants. It will never give you these two quadrants. Whether it is negative output or positive output, it will return values in that quadrant. So for cosine, let me draw cosine. 90 degrees, 180 degrees. Forget about the degrees. We have 270, 360. We have negative 90. We have negative 180. Let me stop here. 1 to negative 1. Cosine of 0 is 1. Cosine of 90 degrees is 0, right? Cosine of 180 is negative 1. Cosine of 270 degrees is 0. Cosine of 360 degrees is 1. So we have 1 here. Let me just use one cycle. So this is how it looks like. Vertical line test, it passed because it will touch exactly one point. But by crossing a horizontal line, it will touch it at this point and this point, which we don't want. So to restrict it from origin, you can see that I can confidently remove this so that we can now have inverted function. So whenever it touches one point, the function can now be inverted. So the new domain, instead of from negative infinity to positive infinity, it will be from 0 to 180 degrees. Or you can say that from 0 to pi, all the same in radian. So where is 0 to 180? This is 0, this is 180. So therefore, whenever you take the inverse of the output, it will give you the new output from 0 to 180 degrees. It will never go beyond this because the domain will be the output, the range in the inverse function. So just look at it. If you have cosine of 30 degrees, it will give you root 3 divided by 2. And you know that you can have another one here, right? Which is 330 degrees because cosine depends on x-axis. So if this is positive, this will be positive as well. And if this is negative root 3 divided by 2. The one here will also be negative root 3 divided by 2. You should know that. So here we have negative 1 over 2. Which angle is this? 180 plus 30. That is 210. So this angle is 210 degrees. So if you take cosine of this angle, it will give you this. And cosine of 360 degrees again, cosine, I don't have to waste time because you have really understood what we mean here. It will be root 3 divided by 2. So what happened to cosine inverse of root 3 divided by 2? It means that cosine of what angle will give you root 3 divided by 2? Cosine of many angles, including their coterminal angles. But because of the restriction, we have restricted it from here to here. So you should look at where do you have positive root 3 divided by 2? It's only here. So therefore, if you take this, it will give you 30 degrees directly, and it will discard all the remaining angles, including their coterminal angles. Did you understand that? So therefore, we have seen that sine will return values within these quadrants. This is for sine. And cosine will return values within this quadrant because we have restricted the domain from from 0 to positive 180 degrees, which is going to be your new output in the inverse trig function. So this will be the cosine. So what we need to find is the tangent because I'm going to restrict it to sine, cosine, and tangent. I'm going to use some special angles like 45 degrees, 45 degrees. We have 1, we have negative 1. Let me use 90. You should know that tangent is what? Sine divided by cosine. Tangent of 0 is what? It will be sine of 0 divided by cosine of 0. Sine of 0 is 0. Cosine of 0 is 1. 0 divided by 1 is 0. So we have a point here. But what about 45 degrees? Would be 1. What about 90 degrees? Sine divided by cosine. This is undefined. This is why we have a vertical asymptote here. We have another vertical asymptote here at negative 90. Remember, the coordinate here will be 0, negative 1. So it will be negative 1 divided by 0, which is undefined. So we have a vertical asymptote here. So you can see that the graph will look like this. You know, here we have negative 1 here. So it will be like this. So you will have many of these. something like this, infinitely many of them. But again, if you draw a horizontal line test, it will be touching many curves, right? So therefore, to restrict it, we are going to restrict it from negative 90 to positive 90. So the domain, after being restricted, initially it is from negative infinity to positive infinity, but because we want to have an inverse, we have to restrict it from negative 90 to positive 90. We should know that 90 and negative 90 and positive 90 would not be included because it is undefined at that point. So it will be from 90, negative 90 to positive 90 degrees, or from negative pi over 2 to positive pi over 2. So this is the domain after being restricted. So it will serve as your output in the inverse trig function, that is arc tangent of that angle you are looking for. It will give you result within this range, which is the same thing with sine. So we have seen sine and tangent will return values within the first and the fourth quadrant, while cosine will return values from 0 to pi or 180 degrees. So I only wanted to show you where inverse trig functions returns values, and that's just the main purpose of this tutorial. If you are looking for sine inverse, expect to have values within this quadrant. If it is for cosine, expect it to be from 0 to 180. So subsequently, we are going to solve many problems. Thank you for watching. Do share to your learning colleagues. Bye-bye.